Hello again, everyone. We're going to continue on with our notes today. Again, I'll go through notes and I'll tell you which problems I want you to do during class while I'm out. This is our last video lesson, and then we'll be back in person tomorrow on Wednesday. Okay, so this section we're going to learn about isosceles and equilateral triangles, so just a little bit more in terms of their properties so we can use it to solve for unknowns in a triangle. These will pop up all over the place later on in trigonometry. You'll see them. Okay, so an isosceles triangle, we already know that it has two sides are equal length. Okay, the legs, these are the two sides that have equal lengths. So a leg is the term for like this side or this side. So a leg is side with equal length. And then the base is the side with different length. The vertex angle is this one right here. I don't know, this is the base angle. Wait, let me be sure. I gotta check my notes here. All right, let me pause this. Okay, so the vertex angle is this one right here. So there's one vertex angle. So this is the angle across from the base, and it's formed by the two legs. Okay, the base angles are numbers 2 and 3 here. So these are angles adjacent to the base. Okay, again, adjacent means next to. So 3 and 2 are next to the base. Angle 1 is across from the base. So this is vertex. This is base. Base. These are angles. Okay. There's the main property that you can use for an isosceles triangle is that if two of the legs are the same length, that means that the two base angles are congruent as well. So if these legs are congruent, then the two base angles are congruent. Again, congruent, equal, they mean they're equivalent expressions. So if two legs of a triangle are congruent, then the two base angles are congruent as well. Okay. The converse. Okay. We learned about this in our second unit. It's been a while. So I'll do this for you all. So remember that the regular statement was if two legs are the same, then that means the two base angles are the same. The converse is where you switch those two statements. So now if two angles of a triangle are congruent, then two of the sides will be congruent as well. Okay. Okay, so now we got to name two sets of congruent sides and two sets of congruent angles. All right, so I know that AB equals AC because that's given. Again, the number of tick marks, if these both have one tick mark, that's a geometric diagram way of saying that this line segment and this line segment are the same length. So I can say AB is equal to AC. That's one set of statements. Okay, then here's where I'm using that theorem. Okay, there's a triangle right here, and two of the angles are the same, right? D and C are the same angle. What that means is that this is an isosceles triangle, and that this leg is going to equal this leg. Again, because if we've got two angles of a triangle, they're congruent, then two of the sides will also be congruent. And we know from our setup that the base angles are the ones that are congruent. The legs come up from the base angle. So it's not, we don't have anything to say about this line right here because it's between the two base angles. What we can say is that the two legs will equal each other. So this one has one tick mark. That one should also have one tick mark. Again, that's just a way of saying that this line is the same side. So now I'll write that down. So AD is equal to AC. So those two. All right, and then our sets of angles, I will say angle D equals angle C, right? That's given. Those are drawn out. And then I'll use my theorem here. If two sides are equal, then the two base angles will be equal as well. So that means that this angle is going to equal this angle. I'm labeling it with two arcs because this angle is not the same as this angle C. But it is the same to B. So I'm going to say angle, I'm going to call this angle 1, and that'll be angle C. Okay, so I'll say angle 1 is equal to angle B. Again, I just gave that a different label because you can't really tell which one is C unless you draw it out, because C could be referring to two different angles. Okay, I'm going to have you do this one. All right. Now we're going to move on to equilateral triangles. So an equilateral triangle is a triangle where all the sides are equal. Here's our theorem for this. If a triangle is equilateral, then it is equiangular. And I'm just going to say 60 degrees each. So anytime you've got an equilateral triangle, it's going to have 60-degree angles for all of its angles. Converse is if a triangle is equiangular, then it is equilateral. Cool. Okay. All right, so now what we'll do, I'm going to work through this one for number 4, and then I want you to work through this one. Our goal is to label each of these. I think it's just example problems from here on out. Yeah. So these are the main concepts that you're going to be putting into practice. Again, this takes a bit of practice, so don't be too discouraged. It'll take a while to pick up. Okay. So I see that these two sides are the same. That means that they're like legs of an isosceles triangle. So that means that this angle here has to equal this angle here. Okay. There's an added step here, which makes it a bit like a puzzle, but I know that these three angles will add up to 180, and I know that this angle is equal to this angle. So I could say 60 plus angle Z plus angle Y equals 180. That's just our plain old statement saying that the sum of the angles inside a triangle always add up to 180. Now I can say that instead of adding Z plus Y, I'll just add 2 of angle Z. So this is the same as saying 60 plus 2 times angle Z is equal to 180, right? This plus this equals 180. Well, that means that this plus this again should also equal 180 because Z and Y are the same. So I'm replacing Y with another version of Z. Okay. Now I'll solve for what Z has to be. So minus 60, I get 120 is equal to 2Z. All right, divide by 2, I get angle Z is equal to 60 as well. So that means this is 60 degrees, this is 60 degrees. All right, now what I realize is that all of these are the same angle. So this is actually equiangular. That means that all the side lengths have to be the same as well. So this would be 8 inches. Okay, so I just used this one for that. All right, I want you to work through this one. Again, label all the sides that you can. As a note, you're not going to be able to label this side here, but you can label these two angles and you can label this side. So don't worry about PM. Determine if the triangles isosceles, equilateral, or neither. All right, so this, again, if I see 60 degrees, that means that this angle here has to be 60 degrees because they have to add up to 180. Then I see it's equiangular, that means it's equilateral, so x equals 16. Again, these are kind of like puzzles, so you should be able to go through. This is equilateral, means it's equiangular. What's the degree measure of each of these angles? If it's equilateral, it's going to be 60 degrees each. Using that, you can figure out what x is. I'm going to do this one, and then I'm going to leave the rest for you to do as classwork or homework if you don't get to. Okay, so I'll start off with this. So this angle, and this angle are all the same. That means they have to each be 60 degrees. If you see three angles that are the same, the only thing that they can be, if they make up a triangle, is 60, because 60 times 3 equals 180. Okay, this is a linear pair here. So this means that this angle plus 60 has to equal 180 degrees. So for this angle, I'm going to label this as 120 degrees, because 120 plus 60 equals 180. They're a linear pair, right? These two angles are next to each other. They make a straight line. That means that that has to be 120 degrees. Okay. Next, I see that this is equiangular. That means that it's equilateral as well. So this side has to be 40. This side also has to be 40. All right, I'm going to tackle y first, and then I'll tackle x. So I know that this side length is 40. I know that this side length is also 8y. That means that 8y has to be the same thing as 40. So 8y and 40 are equivalent. 8y is the same as 40. All right, what does y have to be then? Well, I can do a little algebra and get y is equal to 5. So that's one of my answers. I've also got to find x here. So now I've got 40 and 40 on this triangle. This looks like a different side length. That means that this is an isosceles triangle because two of the legs are the same length. So this is one leg, this is another leg. Because I've got two legs that are the same length, that means that this angle will equal this angle. So I'll just put x degrees here. Again, if that's my isosceles triangles theorem, that if I've got two legs that are the same length, I'll have two angles that are the same. Then I'll set up an equation and try to find x. So I know that this angle plus this angle plus this angle equals 180. So x has to be, I should be able to find it from that. So 120 plus 2 times x, 2 times angle x equals 180. Right? So 120 plus x is the same as 120 plus 2x. All right, to get x by itself, I'll do minus 120 on both sides. I get 2 times angle x is equal to 60 divided by 2. X is equal to 30 degrees. Okay. All right, and that's that problem. So these are sort of like puzzles. They're going to be challenging. It's going to take a while to like really get a good grasp of them. We'll practice these once I'm back, but this is what I want you to focus on for this last video class. I want you to work together on this, so you can, work with your neighbors. It's a lot easier to do these with other people because often you can have a friend who like sees something that you don't, and then you're not just staring at the same thing for an hour. Okay. Good luck, and I will see you all tomorrow.